What's good, Logan? Welcome to another installment of Math from Your Couch. Before we get into it, I want to give a special shout out to all my people that live on the planet Hoth. May the 4th be with you. Stay cozy, keep warm, and stay out of that snow. For the rest of us in Algebra 1, today what we're going to take a look at is this thing called Pythagorean Theorem. So we're going to kind of transition away from square roots, but keep them still in the back of our head because we are going to be seeing them to solve these types of problems. So what we want to do is we want to take a look at what is Pythagorean Theorem. Now, if you can't tell, it's going to be about right triangles. So let me just post up Pythagorean Theorem based on what it says, and this is the definition. I'll just read it to you real quick. Pythagorean Theorem: if a triangle is a right triangle, then the sum of the square of the two sides that make the right angle equals the square of the third side. And if you don't speak this weird language from Star Wars, then you have no clue what this is talking about. And that's what we want to do, is we want to break this thing down. So I'm going to break down that first phrase: the sum of the square of the two sides that make the right angle. All I need you to know right now is we are talking about those two sides right there, the two sides in red. They make up the right angles. When they connect, they make that box, that square right there. Now, for those of you that don't know what a right angle is, it's an angle that measures 90 degrees. When two lines essentially form a square, kind of like that, when the two lines form a square, that's what we call a right angle. Moving on, the third side. The third side is the side that does not touch the right angle. That's across from it, okay? So those are our focuses. Now, the reason why I bring those up is because the formula for Pythagorean Theorem is often just written as a to the power of 2 plus b to the power of 2 is equal to c to the power of 2, or a squared plus b squared equals c squared. Now, this is where the red and the blue are going to come into play here. The red are the a squared and the b squared. So if you have the two sides that make the right angle, then you have your a and your b. All you got to do is square those two things. And if you don't have that, if you have the side, the blue side, the side that doesn't make the right angle, we call that the side opposite to it, or across from it. We're going to square that. Now, the term that you're going to hear used in geometry and algebra 1 is that those sides are called the legs and the hypotenuse. So the two sides that make the right angle, we're going to call legs, and the two sides, the side that is across from the right angle, that's what we're going to call the hypotenuse. Or the two sides that are red are the legs, and the side that's blue is the hypotenuse. Now, that can only be used, that color signifier can only be used for this problem because it's not always going to be described in those colors. All right, so we're going to take this and we're going to apply it. So let's take a look at our first example. The most important thing is not to just be able to read this, but to actually use it. And our first problem, our first example is right here. In example number 1, we have a right triangle where one side is 13, one side is 12, and one side is unknown x. Our job is to find out what x is. Now, what I'd like you guys to understand is that the moment that you have this piece right here, okay, the moment that you have that right angle, what you can do is you can say that Pythagorean theorem will actually work on the problem. So we now know that Pythagorean theorem will work because of this. So we can say a to the power of 2 plus b to the power of 2 is equal to c to the power of 2. Now I'm going to write that up over here. Anytime I have a right triangle, I always write down a squared plus b squared is equal to c squared. And then now I want to figure out if I can use those to solve for the missing piece. So my two sides that make my right angle are 12 and x. So that means that this guy right here is going to be my a, and this guy right here is going to be my b. Now a and b don't matter which one is which. All that matters is that when you look at a and b, when they meet each other, they hit at the right angle. They form the right angle. Now the last side, the side that doesn't touch the right angle, is what we call side C. So now we're just going to plug in the numbers. We're going to plug in 12 for A. So we're going to take that 12 and we're going to replace it where A used to be, plus, and we're going to take that B, whatever B is, which is X, we're going to put that and we're going to plug it in for B, and we're going to take out what C is and we're going to plug it in for what C is. That 13 takes the place of C. And now we have an equation that we can actually solve to find that third side. So we're going to say 12 to the power of 2 is 144, plus x to the power of 2 is equal to 13 times 13, which is 169. So now we're going to solve for x squared. This is just a quadratic. It's one of those special ones where you can isolate the square. So we're going to isolate the squared term. We're going to subtract the 144 from both sides. The result is x to the power of 2 is equal to 25. Now, if you recall, to get rid of a square, you're going to use the square root. So we're going to square root the x squared to isolate the x. But if you square root the left, you're going to also have to square root the right. This gives us x equals to 5. So we now know our third side is 5. So the two sides that make up this right triangle are the 5 and the 12. They make the right angle. And then the 13, that's the hypotenuse. So the legs are 5 and 12, and the hypotenuse is 13. All right, so let's take a look at our second example. If this first example didn't make sense, let's take a look at the second one and see if this one will help us make more sense of what we're doing here. Now, once again, the moment you see a right angle, you're going to want to write down Pythagorean's theorem, a to the power of 2 plus b to the power of 2. Oops, not plus c to the power of 2, but equals c to the power of 2, and I'll write it down here, a to the power of 2 plus b to the power of 2 equals c to the power of 2, and we're plugging in all the pieces. Unfortunately, I don't know what a, b, or c is, so I'm going to look at this real quickly. I know that this side and this side, the 6 and the 2, make up the right angle, so we're going to say the 6 and the 2 are going to be our a and our b, which means the x has to be the c in this problem. So I'm going to plug it in, 6 to the power of 2 instead of a to the power of 2, plus 2 to the power of 2, because b is 2, is equal to, and c in this problem is x. So we're going to go x to the power of 2. And now we simplify. We got 36 plus 4 is equal to x to the power of 2. Combine the 36 and the 4, that gives us 40. We have 40 equals x to the power of 2. And now we just want to isolate the x. That means get rid of the square. So we're going to square root the right side, which means we have to square root also the left side. So we're square rooting both sides of the problem, and we have square root of 40 is equal to x. And while this answer is correct, it is not the simplified answer. So I want to break this guy down just a little bit more. So I'm going to simplify the radical by breaking it down to a perfect square. So I need to think of a perfect square that can multiply to give us 40. So we try 4, 9, 16, 25, 36. Notice I'm using perfect squares. The first one that I said, though, 4 can divide 40 nicely to 4 times 10. So I'm going to use that breakdown for our x. The square root of 4 is 2. The square root of 10 cannot be simplified further, so we're going to just write 2 square root of 10. And our answer is that x, the hypotenuse, is equal to 2 square root 10. If you have any questions, please give me an email or hit me up on Google Classroom. I wish you guys the best of luck and have a great day. Talk to you later.